Do you mind turning off the lights for me, please, and thank you. Okay, so I'll tell you, if I could write this textbook, I would redo it and do it all at the same time. The textbook splits it up into chapter 3, acute triangles, and chapter 4, obtuse. But I am right off the top, right at the beginning, I'm going to mix them up because there is no different scenarios in terms of solving them. You do them the same way. There's just one problem when you're dealing with obtuse triangles, and there's some ambiguity there. You're like, what is that? Ambiguity means you're not quite clear, right? If somebody's ambiguous, they're not being clear. Like, it's like, do you mean this or do you mean that, right? So we will deal with that later towards the end of the book. So I will mix up obtuse and acute, making sure that you never have this problem. And then at the very end, when we've kind of mastered trig, then I throw in that ambiguity component to it. Right? Now you can do 2 chapters in one. I used to do chapter 3, and I was like, okay, chapter 4. And it's like, well, we're doing the same thing, Mr. Dirksen. What's going on here? So let's just do it all at the same time. It saves time, and ambiguity, we'll deal with that later on. Okay? So here we go. So from time to time, I will assign from 2 different sections of the textbook because of that, because they don't mix it up. I want to mix it up, okay? So somehow it printed on this cover, so you're going to have to deal with, hopefully your eyes don't hurt too much. So in IAPR, that's Intro to Applied and Pre-Cal, you learned about primary trig ratios. That's sine, cosine, tan, and you also learned about the inverse of every trig function has its inverse. Okay? Don't say it's to the power of -1. That's not what this is. It's just saying it's the inverse of that operation. These are inverse operations. When did we use inverse? Anybody remember? What would we do? What would we do with the inverse when we're trying to find sides or angles? I don't remember. It's all a blur, Mr. Dirksen. Summer is kind of like a format brain, right? It's to find the angles, right? We use this to find angles, right? To find angles, to calculate angles, okay? So anyways, primary trig ratios only work with right triangles. And grade 11 applied, we will learn to solve for oblique triangles. Oblique is anything that isn't right is oblique. Okay, so here, let me just give you a little sketch here. So a right triangle is a right triangle. We use so, ka, toa. Do you remember that? That you should. You should have heard of it. Okay. If not the biggest deal, because you kind of, what's going on here? It doesn't like a yellow background. I get it. I won't do it anymore. There. SOHCAHTOA, there it is. So I write it like that so you know, right? Your opposite hypotenuse, adjacent hypotenuse, opposite adjacent. But we're not going to use that. I'm going to discourage you from using it unless you remember clearly from last year what to do. Then you have this type of triangle, or you have this type of triangle. Okay. This would be an acute triangle. All angles are less than 90, and this is because this is an obtuse angle. This is actually an obtuse triangle, acute triangle, obtuse triangle, but all of them combined are called oblique triangles. Okay. And for those, we have to use sine law or cosine law. We're going to wait with cosine law for now. Okay. I'm just going to show you how to do sine law. Spend a day or 2 on sine law, then I'm going to start using cosine law. And there is no tangent law if you're going to wait for that one. These are the only two you need to solve any triangle. Okay, so I will make sure these two also work with right triangles. So if you kind of fell asleep on this unit here, an IPR or grade 9, this rescues you. Okay, this kind of like solves that problem for you. Or maybe you struggled with it because it was done online and you were just, everything was kind of dark and gray, right? And now this is the second go at it. So sine law, let's draw our classic, this is my classic oblique triangle that I tend to go to like that. And let's label it A, B, C. The angles are labeled with capitals, and therefore the side lengths, if this is capital A, we call the side across from it lowercase a. Capital B, that's the angle that we're referring to, has a side of lowercase b across from it, and so forth. That's how you label your triangle. Okay? So we would refer to this as triangle ABC. So if I ask you to draw and label, that's how you would do it. Just draw your triangle. And maybe your teachers told you you have to go clockwise or counterclockwise. I don't know what they told you. It doesn't matter. You end up with the same answers ultimately. Okay? So here we go. This is what the sine law says. If you were to take sine of angle A and divide it by the side across from it, that's exactly the same as sine of B divided by the side that's across from it, which in turn, you see the pattern here. If you were to do this, if you were to take the sine of the angle and the side across from it, divide that, right, you would get a decimal. That would be exactly the same as this, exactly the same as this. So notice that they're always paired up like this. Okay, that's one version of it. I'm just going to rewrite it. This is also the same thing. If you were to take the side and divide it by sine of A, that's you. And this is sine and angle B, side C, sine of C. I tend to gravitate to the first one when I set mine up, but they're both accurate. They're both. But notice that if the angles are on top, you have to keep it that way. If you put the side lengths on top, it has to stay that way. You can't just flip-flop, okay? And notice that the angles are always attached to sine. Okay, you can't just have an angle show up on its own. You can't just say angle A over A. That doesn't work, right? Sine is attached to it, okay? Let's keep going. Note that sine law works with both right and oblique triangles, and that's worth highlighting. Some students don't think so. It still works. Still works. Yeah, have a couple highlighters. Might come in handy. Let's test the law. Okay, let's test it. Put it to the test. So this is actually GeoGebra. Anybody heard of GeoGebra? Maybe your teachers used it, maybe not, but you can actually draw something to scale and it labels everything for you. So this is drawn to scale. So if we were to take sine of A and divide it by A, sine of B divided by B, sine of C divided by C. So this is also going to make sure your calculators are set to the proper settings, okay? So we're going to go sine of 22.7 degrees over the side across from it. Notice that I mix it all up here. Side A is this, but you can also refer to this as side CB or BC, right? That shouldn't throw you off, but let's just put 3.74 units underneath it. Take sine of angle B, which is 101.39, divided by 9.51. Right? That's the side across from it. And then just out a bit. And then the last is sine of C. And we might be off by a little bit because I should be using more decimal places. But it should be pretty close. Okay, So now you grab your calculator, and real quick, we need to make sure, because some of your calculators have been used by grade 12 applied. So we switched to radians in grade 12 applied. You want it to be set to degrees. Okay, so once you have this written down, you grab your calculator, right, and you make sure at the top you see degree, right? So just in case, I think I did do this with you, but I'm going to walk you through. You press mode, and the third line here, you have the options between radian and degree, and you should have degree highlighted. Okay, got it? What's wrong? Back to green. Did you charge it recently? Maybe because were you outside for a while? Did it get cold? No? Well, they're getting older. Yeah, that is interesting. I know that sometimes when you dock it, it's red, right? And some students take it, it's like it's still red, and then they turn it off and on, and then it's back to green. So, okay. Anyway, so we were good here, so I'm going to clear my screen. So let's go sine. Let's try this, just a couple with me here. Sine of, see how it always opens the bracket? If all you're doing is figuring out what that is, you don't have to close the bracket, right? So that's, let's divide it right away by 3.74. So you get 0.1032 if you round it to 4 decimal places. Then we're going to try sine of 101.39. Do you notice that it's an obtuse angle, right? It doesn't matter. It still works. You go enter, and then you divide it by 9.51. And that is 0.1031 if you round it. And then we go sine of 55.9. If you're going to divide it right away, I would close the bracket. So if you want to go that divided by 8.03, you get 0.1031. And you're like, Mr. Dirksen, you lied to us because look, right? That's not quite right. And that's because of rounding. I should have used more decimal places, and then it would have worked out just fine. But you can tell that it's very close, right? So it checks out. It checks out. Sine law works. Okay. There you go. I just wanted you to see it firsthand so you know that it works. Okay. That's drawn to scale. Let's continue on here. So there are three cases that you should recognize. This is sine law. But the most important thing is this, guys. This is how you know that you need to use sine law. Is for sine law to work, you need at least one pair. Right? If you somehow, sometimes it's not very obvious, but if you can somehow find a pair, like an angle side pair, you have to use sine law. Because I can tell you already, at the very beginning, you're only going to have one option. You cannot do either or. You're going to have to choose between sine law and cosine law. So if you have a pair, you know it's sine law for sure. Okay? Use sine law in the following cases. Note, okay? Given two angles, find a third before you continue. I would do that right away. A student, recently I was teaching a different course, they're like, well, basically, if you have two angles, you technically know all three, right? And that is true. We know that. So the first one, let me just get my notes right here because I want to get that right, is angle, side. And then you have angle, side, angle. And you have side, side, angle. And this is just for you to see what I'm talking about. So if you have angle, angle, side, just draw one like this, okay? If you have angle, angle, side, pick any two angles. So let's say we know this angle and that angle, and we know a side yet. It wouldn't matter which side, but if you have angle, angle, and a side, you should see your pair appear. I use green to highlight one pair, right? So I'm going to use green, but you should see that pair. Okay. Right. So you're like, bingo, there's a sine law. Mr. Dixon talked about pair. He didn't stop talking about the pair. So there's a sine law, right? Then you have angle side angle. And just focus on the way the letters are. Okay. Angle side angle, it means that you'll have that consecutive order. So you could have angle, you have a side in between them and another angle. It wouldn't matter where you start talking angle side angle, you would end up with this scenario. Okay. And does this look like you have a pair? No, this is what I call the hidden pair. Hidden pair. Okay. Find their angle, right? You use sum of triangles equal to 180, right? Because you've got two angles, and then you actually know that third angle, and bingo, you've got a pair. Okay. That's the hidden pair. So that one is sometimes a little harder to find. And then you have side angle. Side angle. So just think of any two sides, right? Consecutive sides. So let's say we want this side, and you've got an angle, right? So just think of the order, right? Side, another side, and then the angle. There you have your pair. I could have called it angle side, but I don't want, that's not, that would make a problem to my video, right? I'm posting it online. I don't want profanities on the video. Some teachers actually do that on purpose so that students remember. But anyways, let's keep going. Recall. This should help you determine if your answer is reasonable. So when you do a bunch of math, right? The largest angle. Do you remember, did I talk about this in the angles unit? But the largest angle will be across the longest side. Right? If you think of a right triangle, which one was always the longest side? The hypotenuse. Because the 90-degree angle was always the largest angle. I don't know if you ever thought about that, but the smallest angle will be across the shortest side. Okay? So now you know, this is how you can check. It's like, wait a minute, I just did all this math and it doesn't add up, right? Like, why is my largest angle here? I've got the shortest, not like the smallest number across from it. That can't be. So something went wrong. Okay, draw and label the following triangle. You're going to need to know how to do this, right? So triangle DEF has the following information. I will just make sure it doesn't look like a right triangle, because 99.9% of the time, that is not the case, okay? There are some right triangles, but it's rare, okay? So you draw a triangle, pick any corner you want to start. I'm going to start here, D, E, F. If you wanted to start on this corner and go counterclockwise, be my guest, you will not lose any marks for that. So once you have your capitals, this is important. You got to make sure that if this is capital D, there's lowercase d, lowercase e, and lowercase f, right, across those angles. That is important to get this right. And then you just go label it, right? D, side D is 5.2 centimeters. Angle D is 50 degrees. Angle side F is 8.3, right? Am I missing something? Oh, there's 2. Oops, that's a typo. This is supposed to be F. So angle D is actually 60, right? Let's fix that. 60, and angle F is 50 degrees. You don't need to worry about drawing to scale. If the angle doesn't look like a 50, not a big deal, because I just want you to draw it so you know which sides match with the angle. That's the most important thing here. The only exception is if there's an obtuse triangle. If you see an angle that's bigger than 90, I want you to make sure you draw it like this. Let's do this. Triangle ABC. Sorry. Let's go. Angle C is 102 degrees. Side C is 6 centimeters. Angle A is 20 degrees. So if I were to give you something like this, you should realize, okay, that's an obtuse angle, right? So draw it like this. Right? So you go, where are you going to put the C? Right here, right? You want that C to be there. So right now it doesn't matter to me if you go A and B like that, because it's A, B, C still. But that C needs to come over here. That's the only exception where you need to watch out. But side C is 6 centimeters, and angle A is 20 degrees. And you've drawn and labeled this correctly. Do you have a pair? Yes, I do, right? Do we have pairs up here? We actually have 2 pairs. Got one here and one here. And when I talk pair, I know both numbers, right? I know both dimensions. Let's do some calculating, shall we? Okay. Talked about the law, when to do what, how to recognize. There might be some ACs and mental maths that ask you, like, when can you use sine law? In that case, I just would like you to know, right? Notice that all of them have at least one angle, right? There are 2 instances where you have 2 angles, and there's 1 instance where you have 1 angle. Okay. Once we do cosine law, I think you're gonna realize the connection there. Like, when do the letters tell you whether or not you're dealing with sine law, cosine law? Okay, let's do the math here. Applying the sine law, and notice that I talk about sides first. Okay. Determine the length of side B. So where is side B? It's right here. Without me even telling you on the diagram exactly where it is, you should recognize it's there. Okay. Do you have a pair? Yes, in unison, right? You have your pair. For now, I'm going to do that so it sticks out. Pair, therefore, sine law. And the reason I'm doing that is because soon you're going to have to choose between sine law and cosine law. So I'm getting you ready for that. So I have my pair. That's going to be my original setup. In order to find side B, what would I need? I would need to know angle B. I would need to know that. So I'm going to make a note here. Okay. In order to solve for B, comma, I need the angle opposite to it. Okay, you can't, some students would perhaps at the beginning freeze and just like, I need an angle, I need an angle. There's 38, let's take it. If you're going to take 38, which side are you actually going to solve for? You're actually going to be solving for this side, which is not the one they're asking you for. Okay, so we want this one to solve for that one. So angle B is 180 minus 62 minus 38, right? So you've got two angles and you get 80 degrees. I'm going to write that in red so you can now see that it's there. We solved for it. So sine law is actually very easy if you just know what you're doing, right? Sine of 62, I start with my pair every time. That's just how I do it. Okay? And then on the other side, I know that that's equal to sine of 80. How about we keep using red because you can tell that I found that, right? Over side B. Right? Bunch of 80s there. So this is, I need you cross multiplying, dividing. I did some of that in chapter 8. But basically you want to go to the side where the variable is. This is how it works every time, no matter what course you're taking. Side where the variable is, start with the number, then you multiply down, you divide going up. That's how it works every time. Cross multiply diagonally, never just across, right? You multiply and then you divide. You don't need to do the arrows on a test or quiz, but it's just for you to know. So watch what I do. Just to avoid the calculator making a mistake, I actually take this number and then I multiply it by sine of 80. As long as you're multiplying them, 2 times 3 and 3 times 2 is the same thing. Right? Divided by sine of 62. And you should know that all the sines together with an angle is really a number. It is a decimal, right? So don't fear that. It's just, I like to keep it like that, so we use all decimals. So let's practice entering this. Right, so I go clear my screen here, 4.5 times sine of 80, close brackets, divided by sine of 62. Okay, so that's how I type that in. You get 5.02. And we are in centimeters, right? So you're solving for a side. That is how you solve for it. Okay. After one example, I'm already going to get you to try this on your own. Okay, so it says you try on the bottom here. How would you solve for side A using the example I just gave you? So I'm going to pause here and you give that a try, okay? I told you this already, but if you have two angles, right? Two angles given, I would just go ahead, right, and find third. Okay, I would just go ahead and do that right away. So angle C is 180 minus 85 minus 30, and that's 65. Okay, it will probably come in handy anyways. So there we go, you have it. So the 65 goes in here, and lo and behold, now you realize you have a pair. Okay. So always try to see, is there a pair? Is it possible to get a pair? Okay. So pair, therefore sine law. Right? So sine of 65 over 14.5 is equal to, what are they asking me for? They're asking me for this side right here. Careful, okay? So that means that between these two angles, you have to use this one, okay? So sine of 30 over side A, okay? And then you cross multiply and divide. So 14.5 times sine of 30 divided by sine of 65. That is 8 meters exactly. Bingo. This is how you solve for sides. Every single time. Sine law. Not bad, is it? Remember last SOHCAHTOA, opposite, hypotenuse, adjacent, the label. None of that here. You just figure out your pair and then you just go with it. Okay. Let's try another one. On the other side here, page 5. I'm gonna up it a little bit here. Solving for angles. I want to make sure you know today how to solve for sides, solve for angles, but nothing too crazy, okay? You know where we're going, right? Word problems. Dun, 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 right? So once we figure this out, then word problems are going to be okay because we're going to know how to solve, right? Triangle XYZ has the following dimensions. You've got that. Side, side, angle, right? I will tell you for sure how you know. SSA are going to be, that's the special case that we're going to talk about at the end of the booklet. I'm going to start teaching you how to find out without even graphing it that it's an SSA, okay? So just follow me here. Sketch a triangle and calculate the values of angle Z and angle Y. So let's do that. How much room am I going to need? Let me just check here. I want to make sure we don't use up too much space. Yeah, we're good. Okay. So for A, we're going to sketch it. There is no obtuse angle at the moment, so I'm just going to go ahead and solve like that. X, Y, Z. I tend to start at the bottom left with my angles. And so that's going to be my 34, because that's angle X. Side X is 6.2 centimeters. Side Z is 3 centimeters. Okay. And now we're going to solve. Do we have a pair? Yes, we do, right? Pair. Therefore, sine law. Okay, just making sure that is clear. So let's solve for angle. Which angle can we solve for as is? Can we solve for angle Y? No, we can't because we don't have the side length across from it. So you always want to keep them together. We do have side Z, which is across the angle we're interested in. So that's the one we're going to solve for first. Angle Z, I'm going to just go like this. That's what we're solving for first. So we start the exact same way as before. We start with our pair. And then put them like that. And on the other side, we're going to have sine of what? Sine of Z, right? You don't have an angle, so you put a letter in there. Over 3. And notice that I don't put the units down of the bottom. It's okay not to do that as long as you do it at the end. Okay. And at the beginning, it looks exactly the same. Your variable is right here, right? So you multiply up and divide going down. So multiply, divide. Please don't forget to keep sine Z together. Some students just don't like that. It's like, hey, just Z, right? Conveniently. No, it doesn't work that way. So sine of Z is 3 times sine of 34 divided by 6.2. And here I do this. I don't like trains, choo-choo trains like this equals that, equals that, equals that. Don't do that. I actually normally start with my setup and then I work down like that. But this is okay to do it because we're going to figure out what this is. Get a decimal here. Okay, on page 5. 3 times sine of 34 is equal to, and then you divide by 6.2. Here's what I want to say. This better start with 0 point something. Like you actually can write it down. 0 point, let's just figure out what is it. If you get anything bigger than 0 here, you're going to get an error, which means you're going to raise your hand. It's like, Mr. Dirksen, it's not working. You got a math error. And I'll tell you, yeah, you need to look at your initial setup. Did you miss something somewhere? Maybe you didn't label it correctly. Maybe you're mixing up numbers, right? So make sure you understand that. So we will write down a couple here, but we want to use all of them. We want to use all decimals, especially with the calculators we have. So this is so one line, 2 lines, and then a third one. Angle Z is going to be, oh, Mr. Dirksen, you dropped the sign. I know, but it's coming back here as inverse of 0.2705 ... because we're using all of it. So watch how I'm going to type this in. Let you copy it first. You got to press second. It was always second or shift or something anyways, right? So second, and we're going to use sine. So if you press second sine, it calls the inverse. Go up arrow to copy that previous number, paste it in there, close the brackets, hit enter, and there you get your angle. That's 15 point, that rounds to 70, right? We round to 2 decimals. Our angles, we round to 2 decimals. Some questions are going to say round to nearest whole number. I still encourage you to do this, okay? So we found that angle. Perfect. We're done with that. We're still asked to solve for angle y, correct? Let me box this in a little bit. All right, this is what we did to find angle z. Okay, boom, that's there. And for angle y, we're going to use the sum of triangles 180, right? Some students miss that and they do a whole nother sine law just to find that third angle. Don't do it, right? It's too much work. So angle y, right, we're going to find that by going 180 minus 34 minus the one I just found. Angle y is 130.30 degrees, right? So we just figured out y and z, okay? Question, could I possibly solve for side y now? Yes, I could. I have angle y, so I have a pair. I have the angle across from it. Sure, I could. Okay. And B is asking, is this an acute or obtuse triangle? Right? Triangle XYZ is an obtuse triangle, comma, since it has one angle greater than 90. If you need a review on this, chapter 2, I did talk about, the different types of triangles. But as soon as you have one greater than 90, it turns into an obtuse triangle. Solve for side y. I'm asking you to do that now. Watch what I'm going to do. Careful, you have more than one pair now, correct? Because you figured out this angle, which is right here. Technically, you have that pair to use. I tend to stick with the one that I was given. Just in case I made a mistake here, it's not going to carry over. So sine of 34 over 6.2 is equal to, I'm going to use sine of 130.30. That's an obtuse angle. No big deal. It still works. and we're going to solve for side y. Y is equal to, cross multiply and divide, 6.2 times sine of 130.30 divided by sine of 34. See how I go down, down, down? This is going to get you, you're going to lose marks. If you were to go right next to it like this, and then type in all of this on the side here, that would be wrong, because that's not correct, that's not accurate. So set it up, right? A mark for setup, a mark for showing your work, and then you will get another there for, that's 8.46 centimeters. Let's check if things add up, right? The longest side is, according to my calculations here, this is now the longest side, right? This is the longest side, right? And it's across the largest angle. Check, right? This is just a check here, because the 130 is the biggest angle, has the longest side across from it. So it's kind of a bit of a check that you've been doing things correctly. Okay. What's the perimeter of XYZ? Perimeter is just sum of sides. Okay. And so we'll just go 3 plus 6.2 plus 8.46, because this does show up from time to time. Oops, 17.66. We are in centimeters. There you have it. This is sine law, guys. Basic in its most basic form. But now you know how to solve for sides and angles. This page 5, mixes it all up, right? We're solving some angles, we're solving for sides. What do you call it when we solve for everything in a triangle? We call it solve the triangle. If you solve the triangle, it asks you to find everything, all three angles, all three sides. Okay. Let's keep going here. There's one more item of interest. I think this is the last page, and then we'll leave the rest for tomorrow. Okay. Multi-step questions. This is when you're like, wait a minute, I need more information. It's like, yeah, you need to figure out information before you ultimately answer what they're asking you for. In some instances, a question will ask you to solve for a side or angle that cannot be done in a single step. In such cases, try to see what can be solved first, then solve for the other dimensions. Okay, so for example, you get, this is an obtuse triangle, right? Determine the length of side Q. And you look at, did I type, there's a typo there, right? Because I already know Q. Yeah, I made a big note, fix this, and I didn't fix it. Side R. Let's fix this. Side R, okay? So where's R? It's right here. That's what it's asking you for. So before we call it quits, I want you to try this first. How would you approach this based on what you've learned? Use your notes, right? And kind of find your way to that ultimate answer. Try to think it through. Okay. I liked what I saw, so that's good. So yep, you identify your pair, and yeah, sometimes it's just, let's write that down and then see where we go from there. Right? What can I do? I don't have angle R, nor do I have side R, so noticing this side, I can solve for sine for Q, right? So I go sine of Q over 9 inches. Okay, so this would be step 1. And so then you cross multiply and divide. So sine of q is 9 times sine of 103. So if you got this, you're just enjoying the ride. Okay, so you got that. That's a good setup. That gives you 0.6904, and that keeps going. Okay, next is angle Q is sine inverse of that. Show me this step, okay? It's important. Don't just rush to the answer. And this is 4367, which I saw a number of you getting. So this is underlined. This is not, I'm not going to circle it, but that's definitely, you're on the right track, okay? Next, I don't call this a step, but I'm going to find angle R here, right? So angle R is 180 minus 103 minus the one I just found. Okay, angle R is 33.33 degrees. Also important to me. And here's step 2. You can call it step 2 and then step 3. Sure, why not? But I'm more interested in these two, right? This is like an in between. Then we go. I'm going to use the same pair that I was given. Okay, but in this case, I'm going to go sine of R over side R. Okay, and then you cross multiply and divide. Cross multiply and divide. So 12.7 sine of 33.33 divided by sine of 103, and that is 7.16 inches. That is the final answer, and so that had to be done in multiple steps, right? So be consistent with your work. Know what you're doing. Things need to be opposite each other, and then you will succeed. Okay. I saw very good signs, like you were doing the right thing. So here's your homework, and it's a little bit spread out. Let me just quickly peek into the textbook, because I know the workbook makes you sketch them from scratch, label them, and then solve, which is what I would suggest. So page 124, 1 to 5. Yeah, so there they give you the diagrams, right? And you're just supposed to solve for what's missing. There are 2 word problems there, but they do have a diagram. So give it a try, right? That's a good introduction to word problems. You should be able to use what you've learned today to answer what they're asking you for. And then in the workbook, skip the first page, that practice worksheet. Just go straight to page 3 here. And I give you lots of space here to sketch them and solve for what they're asking. Okay? And so tomorrow you can expect an AC on sine law based on what we've learned today. Okay? Thank you very much. That's it for today.